Homework 4.2, Logarithmic Functions, Video 2. Homework due Friday, May 29th at 11:59 p.m. You may have noticed in the previous video and the current one that I have not put any associated homework questions. That's because we're still developing the idea. In the next video, and most videos after that with the exception of one, there will be homework problems associated with the video. Alright, so let's formally define a logarithmic function. We start by taking a number b that's positive and at the same time it's not equal to 1. You may recall that those were the same restrictions imposed on the base of an exponential function. And the reason we're imposing those restrictions again is because the b will be a base essentially in the context of an exponential function. So we have the same restrictions here. This number is positive, but it's not equal to 1. Then f of x equals this, which is read log base b of x. Remember, it's a function. F of x, log of x. But we have to announce the base in between. So log base b of x. But log base b of x is the unique power, because there will only be one answer per log, the unique power that turns b into x. In other words, when you do an exponential function problem, I give you the base and the power, and then you give me the answer. A logarithm kind of works backwards. A logarithm gives you the base, but not the power, but it gives you the answer. And the question is, what power do you put on this base to get this answer? So for example, let's take a look at this one. If f of x equals log base 3 of x, what is f of 81? Well, first off, let's substitute the value like we do in any function problem. F of 81 would be log base 3 of 81. Now, what does that equal? Well, what question is it asking? Or what is it asking you for? It is asking you for the power that turns the base into x. In this case, x is 81. So whatever this is, it's the power that turns the base, which is 3, into 81. So I may not know what the answer is yet, but I know what the answer does. As a power, if I put it on 3, it'll turn it into 81. Now, you may know what that power is, but let's pretend you don't for a second. Since I know what the answer is supposed to do, I can just guess and check. So over here, I'm just going to start whipping out powers of 3, starting with 3 to the first power, which is 3. That's not what I want. I need to turn the 3 into an 81, not a 3. 3 to the second power won't work either, because that's equal to 9, but I want to know what power turns the 3 into 81. Now, you may want to use a calculator to do some of these exponents, but 3 to the third power is 27, and when we get to 3 to the fourth power, that's 81. 4 is the power that turns 3 into 81. I'm being asked, what is the power that turns 3 into 81? And so the answer is 4. Because, not to sound like a broken record, 3 to the fourth power is 81. So that's all a logarithm is asking. What power turns the base into the input? And there's a vocabulary word that I've yet to sneak in, but I'm going to sneak it in now. The input of a logarithm has a special name. It's called an argument. Technically, the input of any function is called an argument, but for logarithms, I want to focus on that. So another way of thinking of this, a logarithm is asking the question, what power turns the base into the argument? What power turns the base into the argument? What power turns the base into the argument? In this case, what power turns 3 into 81? So a logarithm is a question, and the question is, what power turns the base into the argument? Now, in the next video, we're going to evaluate that's 2 videos down the road, but we will be evaluating several logarithms so that it will become instinctive, hopefully. But before we leave this video, I want to introduce you to two special logarithms. In previous videos, I've shown you close-ups of calculators, and there were a couple of buttons on them that we will begin using very soon. One of them says log, and one of them says ln. When you see log without a base, that's what this one is. Log without a base means log base 10. This is what's called a common logarithm. Common logarithm. So again, if you see a logarithm without a base, it is an implied 10. If you have a calculator, this is easy to remember because above the log button is 10 to the x. Why? Because these are inverse functions. So that being said, here, if you have your calculator, take a look at the ln button and what's above it, and see if you can predict what I'm going to say here. Because ln is also a special logarithm. Ln x means something special, something specific. It's a log with a predefined base. Do you know what the base is? Well, what's above the ln button? E to the x. And the base there is e, and the base here is e. The reason it's called ln is because this is the natural base. ln stands for natural logarithm. Because its base, its implied base, is the natural base. Go back and watch the previous video if you forgot what that means. So if it's natural logarithm, why is it ln? I know the answer to that. Well, my wife had to tell me. She's a math teacher with more sense than me, I would like to say. But the reason natural logarithm is abbreviated ln is because the mathematician who invented logarithms is French, or was French. He's been dead a long time. And why does that matter? Because just like Spanish, in French, when you say an adjective and a noun, you usually say the noun first, followed by the adjective. So in French, this would be logarithm naturel, or however you would say it. Hence, ln. So keep in mind that anytime you see log without a base, it means base 10. But if you see ln, it means base e.